Hi guys, welcome back. In this session, we're continuing PS Bhimbra backside questions. We already done 110 questions on DC machines. We're now continuing that with the part 13. If you want the full playlist, you can check the link in the description. And these questions are really amazing questions. You can see in this session also, we got some really beautiful questions. Basically, mostly towards the testing. Today questions are towards testing almost. Okay, and you're going to learn some very interesting insights, very minor but very key insights you're going to learn with this session. Okay, let's jump into the first question. Yeah, try to answer this. Take a second time, take a minute time, not more than a minute. Try to answer this. I think you'll be able to make this question very easily. Try, give it a shot. Read the question properly first, then you try to answer this. I think you're going through it. Okay, this is an easy one, but a tricky one. Okay, so it says we're talking about a DC series motor. DC series motor fed from a rated supply voltage means it is given a full rated voltage and is overloaded. Overloaded means what he's trying to say is he's trying to say magnetic circuit is saturated, because in case of a DC series motor, immediately you should be able to recall the series motor structure. Okay, this is the series motor. So when it is overloaded means it is taking more armature current than the rated current, means the field current is much above the rated current. That's what he's trying to say. Magnetic circuit is saturated. He's even explicitly mentioned that. Okay, so in case of a DC series motor, we know Ia is proportional to, phi is proportional to Ia, means flux, series field flux is proportional to Ia, but with the help of this magnetic saturation, phi is no more proportional. He's trying to say phi is constant. Phi is constant. Under this case means this is the case he's talking about. This is the below rated case. This is above rated case diagram. Okay. So in that case, phi is constant. Flux is constant. Now the question is the speed torque characteristics. NT characteristics. In case of a motors, there are three different characteristics. One of that three is speed torque characteristics. Okay, we know, as in case of series motor, if torque is increasing means current is increasing, flux increases, speed reduces. But we know N is proportional to EB by phi. So as torque is increasing, flux is increasing, speed is reducing. So this will be something like this. This will be something like this. Means if I continue like this, this will be something like this. Hyperbolic curve you will get. Okay, we know these characteristics. Now, after this, what is the case? That's what he's trying to say. So once flux is constant, so N should be constant if EB is constant, but N is now proportional to EB, where EB is equal to terminal voltage minus IA RA plus RSC. Okay, IA RA plus RSC, series field resistance. Now this is IA is increasing, so this drop is increasing. So speed will reduce proportionally. Okay, so not this curve, this will be the curve. Speed will reduce because as current is increasing, this will increase. This will increase, so speed will reduce. It's a linear relation. Okay, straight linear relation you will get. So answer is curve B. Okay, so it's not that speed will increase. Okay. Anyways, I think you got the points. These are the minor and key details which you will definitely know if you go through the lectures. We have amazing animated lectures. You can just visit our courses. Some of the free videos also there, and online tests also there. Not just this. Of course, you are going through these backside questions of PS Bhimbra, but we have some beautiful online tests which are asked in different exams. Okay, you just try to appear those tests. This will be, it just gonna cost you very less from 99 rupees, I think. With a detailed explanation, you'll get all those questions. That will give you a great help, great push to your upcoming exams. What are the exams coming? Be it GATE, be it your upcoming transcript exam, whatever. Okay, and if it is power systems, everyone must get to this. This is CL Wadhwa questions. Nowhere you will get these solutions for CL Wadhwa, but in this course, you will get a detailed solution for every question of CL Wadhwa is included in this. Okay, this is going to help you a lot. It's not just question to answer. In this specific package, we introduce some of the concepts also with the help of the questions. In the explanation also, some extra concepts what frequently asked, that also we have introduced here. Okay, you can check that out. Let's go to the next question here. So from now, I think you'll get some really interesting questions. All out of next 9 more questions are there. And the 9 more questions, 7 questions will be amazing questions. You just check it out. Check this. These are the reason why everyone likes this PS Bhimbra backside questions, because from these questions you can frame a lot more questions. Okay, let's see. Try this first. Try to answer. When it is right or wrong, just share your thoughts. Nobody's going to know. Nobody's going to judge you, by the way. So you can share your answer. I think you made your tries. Let me give the analysis. Consider the following statements. Permanent magnet DC motor. Whenever, in case of a machines, if a motor or a generator, if a specific machine is named, you have to have the schematic diagram of that machine. It is said permanent magnet DC motor. Okay, so there is a permanent magnet and armature, and it is used for cassette tape recorders. Okay, in case of this, so permanent magnet type motor, and it is used for cassette tape recorders. I mean, earlier days tape recorders. I think nowadays people may not know the tape recorders. Everybody is playing the music or mobile phones. Okay, but I think you guys must be knowing tape recorders earlier. There you used to have permanent magnet DC motor. Okay, what's a permanent magnet DC motor? Permanent magnet DC motor means stator side, outside you will have a permanent magnets, inside rotor is armature. That's what the permanent magnet, right? Permanent magnet motor. So magnets are on the stator and the armature is on the rotor. Absolutely right. Magnets on the rotor, armature on the stator. No, this is wrong. Okay. Usually this is the case for BLDC. This is the case for BLDC motor, where outside there are magnets, inside there is armature, and inside is fixed, outside is rotation. Okay, so magnets are rotor and armature is stationary, which is inside. That's important point. Yeah, in case of BLDC, it's true. We explained all these BLDC motors, special motors with the beautiful animations. We explained all of those in our courses. Okay, so electronic commutation and no brushes. Yes, if it is a BLDC, this will be the case. Yes, if it is a BLDC, this will be the case. In case of BLDC, the commutation and commutator is absent in case of BLDC. Brushes are absent in case of BLDC. Then if that is the case, how the commutation has to happen in case of DC? That happened due to the electronic commutation. Okay, commutator as in mechanical commutator is absent in case of BLDC. Okay, but that is special motor, BLDC motor, not a permanent magnet type motor. If you're using permanent magnet type motor in case of a cassette tape recorder, definitely you're not going to use this BLDC, because it is explicitly mentioned we are using a permanent magnet DC motor. Okay, so this is also won't be true. Okay, and mechanical commutation brushes, that's the only way. Mechanical commutation brushes must be used. Any DC motor except the brushless DC motor must have a commutator. That's one of the drawbacks of DC machines. Okay, one of the biggest drawbacks of DC machines, commutation. But commutation is very important for in case of a DC machine. Okay, that's why when you are going to this BLDC. So statement 1 and 4 are absolutely true, and 2 and 3 are wrong. So this is wrong, and 1, 4 are, possibly this could be right statement, and this is also wrong statement, and possibly this is a right statement. You'll have to check this automatic speed governors. Automatic speed governors. According to Bhimbra, they said answer is option B. Option B is answer, means they're trying to say automatic speed governors are not used. Automatic speed governors are not used. That's what is said as per the PS Bhimbra. But according to me, in case of cassette tape recorders, of course, permanent magnet DC motors, they themselves are the constant speed motors, almost constant speed motors, but slight variation in speed will be there, though they are almost constant, but they're not exactly constant speed motors. But to maintain that, you may have to use automatic speed governors, might be used. Okay, so now there is an ambiguity. So what I would say is this is also possibly right. Okay, so out of these two, now you have to apply your mind which one you should pick it up. Okay, so out of this ambiguity, though he said option is B, I'm trying to give option as D. Okay, but if I had to justify option B is correct, yes, you can justify, because a permanent magnet DC motor itself is a constant DC motor, so you don't have to go for speed regulators. That's what the justification for Bhimbra answer, but I still want to go with option D. Okay, you can share your thoughts on this in the comment section. Okay, Bhimbra official answer is this. Anyways, let's go to the next question. And Manusha is saying absolutely D is answer. Very good, Manusha. Now try this out. This is easy question, which every one of you can answer. Yep, done. Okay, these testing questions, whenever these testing questions comes, especially for DC machines, by the way, DC machines is very important to understand any further machines. You may think that from DC machines are very less number of questions might come, so I'll only focus on the key aspects of DC machines like characteristics, because mostly characteristics and armature reaction is the main focus for the questions to be asked. But I recommend you to go for the entire DC machines, because that will give you the basic fundamental concepts, amazing concepts you will get from DC machines. Once you understand those concepts very clear, then you can very easily understand any further machines, because right now there are a lot of machines coming up. Okay, all those machines you'll be able to understand once you understand the DC machines properly. Okay, so I strongly recommend, not for the exam point of view, for the concept point of view, you should remember, you should understand, you should keep in your mind all concepts of DC machines. Now coming back to this, whenever you see testing of DC machines especially, you have to recall the diagram. Swinburne test or no load test will call, or indirect test will call. I gave all those details in our course with the beautiful animations once again. Okay, so this testing, though in a laboratory you must have done these testings, but you really don't know, because one of the person in your laboratory, in a team, will be performing all the tests. Everybody else will be just copying the values. Okay, so though you should be having more knowledge on the test, but eventually students end up in gaining no knowledge on this test. So tests are very important. Okay, by keeping those in mind, we developed the test in our course also. We gave the test with the practical simulations also. Okay, anyways, so recall the diagram first. For the Swinburne's test. You have to have a picture of the Swinburne test. Swinburne test is conducted on it's a no-load test. So for a series motor, you cannot conduct the no-load test. So it must be a shunt motor. Yes, you can see a shunt motor over here. Shunt motor, and it is no-load test, means you're not applying any load. So we are basically finding out the no-load losses, and you'll estimate full load losses mathematically. Means on paper you will do what are the losses, what are the copper losses at that particular load and all. You will do that estimation process. But by finding out the no load losses from the no-load test. That's what a Swinburne test. Okay, so in Swinburne test of a DC machine, the shunt machine is running gas. Shunt machine is a shunt motor operating under no load condition, not a shunt generator. It is a shunt motor, means you will give a supply. You will give a supply and you will not put any load on the motor. You will not put any load on the motor. So it is a shunt motor at no load. At no load and rated speed and rated voltage. Rated speed and rated voltage. So this is the right answer. Shunt motor at no load, rated speed and rated voltage. Okay, these were the Swinburne test or no load test or indirect test. And we'll have for any machine, you see, testing is one of the key aspects to find out its performance. Like the way in your class also, your teacher will conduct a test. Why he's conducting a test? To check your performance for studies, during studies, at your studies. In the same way, to know its performance of any machine, we will have to put a test. Okay, by doing a different test, it's not that there is one motor which is very bad, one motor is very good. There is nothing like good and bad. By testing, we will know which motor is suitable for what kind of application. Okay, so to map the application properly, you have to test it properly. Okay, that's why the reason we do the test. Let's go for the next test, next question. Yeah, look at this. This easy question once again. Hopkinson test, or also we'll call it as a back-to-back test, or also we'll call it as heat run test, because there are some drawbacks in case of your Swinburne test. Swinburne test cannot be conducted on series motors. Why? Why, tell me? Give it in the comment. What will happen if we try to conduct Swinburne test on a series motor? Give it in the comment. Yeah, go for this. Hopkinson test. Quick, easy question. Yes, I think you got it. Hopkinson test of a DC machine, it is conducted usually on shunt machines. DC shunt machines, two identical shunt machines. You have to keep that picture in your head. Hopkinson test means, yes, you have here. Hopkinson test, two machines, one machine. I think this question is normally asked by students. Sir, there is a fan rotating at my home. There is a fan rotating at my home. So I will connect a generator, because it is anyways running. I will connect a generator to it, to the fan. So it will generate free energy. How many of you have this question? Give it in the comment. If you have the same question, my fan is freely running anyways. So I'll simply connect a generator and generate electricity from the fan. By taking the air, I'll also generate electricity. These kind of questions students do ask. Is it possible? Is it really possible? Just give it in the comment. Anyways, this is what exactly is doing. This is what exactly we're doing. What we're doing here is, motor is there. I'm connecting motor to a generator mechanically. Mechanically, I'm connecting motor to generator, and electrically, I'm connecting generator to the motor back again. Back-to-back test. Because generator needs mechanical energy that is given by a motor. Motor needs electrical energy that is given by this generator. Back-to-back. So this is the beautiful test, Hopkinson, proposed by Hopkinson. So Hopkinson test. Now for this test, what will happen during this test? During this test, yes, there is some power drawn by the input. Means from the input source, there is some power drawn. Though they are connected back to back, this is supplying, motor is supplying the energy required to the generator. Generator is supplying energy required to the motor. They're exchanging the power. But still you need power supply. You need power supply. Why do you need power supply? That's the question. Yes, to supply the losses. To supply the losses, not in just one machine. To supply the losses, power supply. The power consumed by the power supply, power input taken by the power supply is to compensate or to assist the losses on both the machines. Okay, this is one of the beautiful questions, and there are very good questions framed on this Hopkinson test. So you can see those questions right now. But To answer those questions, you have to have that Hopkinson test, that circuit schematic diagram in your head. Okay, try to freeze this. Try to take a mind shot of this image, not a screenshot, it's a mind shot. Okay, screenshot means here, mind shot means here. Take a mind shot. Have you taken the mind shot of it? Good. Because you're gonna answer beautiful questions on this Hopkinson test. Okay, take a mind shot. Take a mind shot. Done. Let's see. Next question. Let's see how many of you are going to answer this question. Yep. Try. Sumit Pawar has exactly said, speed will become dangerously high if you conduct a DC, no load test on DC series motor. Absolutely right. Absolutely right, buddy. Yep. You got some idea about this? Very beautiful question. The next question also pretty much similar. I will try to explain this question. You try to answer the next question carefully. Okay. Read the statements nicely. Okay. Because I'm giving more time so that you'll understand this question and you'll understand the options statements carefully and answer the next question. Okay. Next question also pretty much similar to this. Two DC shunt machines are coupled mechanical and electrical. That's what he's trying to say. Hopkinson test. Two shunt motors are connected mechanical electrically means it's a Hopkinson test, back-to-back test, heat run test. Okay. Can you name the similar test and transformers also will do? What is the test name? Don't get confused between these two tests, the names. Give me the test name in the comment. Transformers also will do that. Yes. One of the DC machines is run as a motor, another one is run as generator. Their no load rotational losses are equal. We will consider, if not exactly equal, we will consider their no load losses to be equal. Why? Why? Because definitely no load rotational losses, to be more precise, no load rotational losses does not include what? They does not include the excitation losses or field losses are not included. No load losses means it includes field current losses also, field resistance losses also. But if it is said no load rotational losses, it includes only rotational losses, means frictional losses, windage losses and iron losses. Okay, they are equal because their speeds are equal, okay, because all these three are depending on speeds alone. Okay, and excitations of these two, if you look at diagram, they are not exactly equal. Don't get confused here. Though it seems like you are connecting both the excitations in parallel to the constant power supply, but there is a rheostat. This rheostat will ensure there is a difference. It's not that current is always same, though identical machines, though they're in parallel, though there is a constant voltage, but this rheostat will not, because of this rheostats, the currents, these two current, this current will not be exactly the same. Okay, they're almost same, but you cannot claim they're exactly same. So I'm not going with this option. Okay, I'm not going with this option. Only speeds are equal. Next, generator iron losses are more than motor iron losses. I don't think the true generator iron losses are more than. Okay, we'll see this point. Okay, we'll see this point. Let's go to the next question. Next statement. Motor armature current is less than generator armature current. Can this be true? Look at this diagram. They're talking about this motor armature current versus generator armature current. Okay, it is said motor armature current is less. No, actually motor armature current is more. Motor armature current is more compared to generator armature current. Okay, so this is a wrong statement. So we are ensuring statement 1 is correct in all, it's there. Statement 2 is anyways it's wrong. So in all of this statement 2 is there. So only I think I can directly say option D is correct. Option D is correct because that's only by looking at the first two options itself we got to know what is the right answer. Option D is right answer. Okay. Next, somebody is asking about AP discoms. Okay, we'll come to that. Next, motor has more stray load losses than those of generator. Motor has more stray load losses. Yes, we can say this. Stray load losses are more in case of a motor because we know stray load losses are proportional to the armature current. We know armature current of a motor is more. If armature current of a motor is more, see, it is not about stray losses, it is about stray load losses. Stray load losses are not constant. Stray losses are constant. Stray load losses are proportional to load. I mean, they are proportional to armature current. Armature current is more. Motor stray load losses are more here. Okay, statement 5 is right. Now coming back to this, though it is immaterial, though we got the answer, coming back to this, we got one thing here, armature magnetizing current is more compared to generator, sorry, not magnetizing current, armature current. Okay, this is clear. Try to keep another point clear. Generator iron losses are more than motor iron losses. Generator iron losses. Generator means he is trying to say, with this he is trying to say, shunt field current of a generator is greater than shunt field current of a motor. That's what he's trying to say. Means with the third statement, yes, it is true. It is true. Flux, the excitation is not equal. I'm saying, right, excitation is not equal. This is wrong statement. If excitation is not equal, in case of a generator, you need more excitation. In case of a generator, you need a more excitation because they must be at the rated condition. They must be at the rated condition. Okay. For the same rated voltage, this voltmeter should read 0. Perfect. That's the Hopkinson test. When you perform the test, you will do this kind of voltmeter and you will ensure that this voltmeter is reading 0. Under such condition, this is rotating at rated speed. This is at 0 voltage. Under such condition, you will see this has less current compared to this. This has more current. Okay, so try to keep these points in your head. So option D is right. Option D is right. Shall we go to the next question? And next question, you should be able to answer it. You should be able to answer it, and you should answer rather, because I explained all of this clearly. So next question should be clear. I'm not going to answer the next question. You just try and give it in the chat. Give it in the chat and a comment. What do you think? What will be the right answer for the next question? You should be getting in one read itself. Armature currents of both machines are equal. Wrong. Motor has more current. Armature current. Generator is less current. Absolutely right. Generator is having less current. Absolutely. The speeds are equal because they're mechanically tight, mechanically coupled. Their field currents are equal. No. Generator has more field current compared to the motor. Okay. Stray load losses in a motor is more. Absolutely right. Absolutely right. So 2, 3, 5. Statement option A is right. Are we clear? Shall we go to the next question? Good. Very good, Sumitji. Perfect. Yes. Hearts for Sumit. Try answering this. Oh my god, lot of hearts to Sumit for giving right answer, I think. Next question. Next question also Sumit is saying A. Careful here guys. It is about two DC series machines. So for Hopkinson test, we call it for shunt machines, not for series machines. Hopkinson test cannot be done for series machines. Okay, but it is said for series machines are mechanically coupled. Series machines are mechanically coupled means what is the test you're trying to say? What is the test name? Very good. Very good, Sumit. Very good, Akshay. What is the test name? Name the test. It is a field test. Field test. Can you quickly recall the diagram? Wow. Our team is amazing. They projected the diagram for you. This is a field test diagram where two DC machines, identical DC machine, these series machines are coupled mechanically, and their series windings are connected. This is a motor series winding, this is generator series winding. They are connected to the supply like this. So because of this mechanical coupling, their speed is same. Because of this electrical connection of series field windings, their excitations are also equal. So option B. If you have the diagram in your head, it will be very easy to answer. If you don't have the diagram, you will never be able to answer this question. In case of Hopkinson test, only speeds, but if it is a field test, both. Okay. There are different tests. Why do you conduct this field test? Tell me. Hopkinson test is conducted to find the efficiency along with the temperature rise. How much temperature is raised during the operation of full load? Okay, if it is a Swinburne test, it will only find out the efficiency, but it will not be able to find the temperature rise under operation. For a DC shunt motors, both the cases. If it is a DC series motor, yes, field test is used to find the efficiency along with the temperature rise. Efficiency of a DC series motor can be found out by using field test. Okay. Yeah. Let's go to the next question. Wow. I think you'll be able to answer this if you have the diagram what I given in the previous slide. If you keep that in your head, it will be very easy to answer this question. It is a little tricky, but I think you'll be able to make it. Straight away, you will strike out this and you will say this is right. It's easy to answer, but now we need to figure it out which one of these two is correct. It is said, see, VTG means don't consider this terminal, it is armature voltage. It is said armature voltage, they're calling it as VTG of a generator. Armature voltage is VTM for this. Okay. See, in case of armature voltage is it is EB basically. Armature voltage is EB for a motor, EG in our terminology. It is EG for a generator. Okay, so it will be easy if I write it as EG and EB. You'll be able to answer this. Now tell me, if you take it as EB and EG, what is correct answer? EB is equal to V minus IA RA plus RSC into 2, because you have two series windings. If it is generator, it is terminal voltage plus IRA, there is nothing IRA and all, simply terminal voltage, because in case of a field test, you will not have series field winding in series. So terminal voltage is same as this. Maybe some brush contact drop will be there. So even by looking at this, you'll be able to answer very easily. Terminal voltage is of a generator. It seems to be more here. Armature voltage of a generator is more. It's put it differently, because their flux is same, their EBs are exactly same, to be more precise. Yeah, we should not come to this conclusion here, because EB, EG will be just the same, because we know induced EMF is proportional to phi into N. Yeah, I think this is wrong analysis. These are utter shit analysis. Why? Because induced EMF is proportional to phi into N, whether it is a motor or a generator. Now these two are constant anyways, so induced EMFs are constants. So armature voltage means he's not actually trying to say these two, because these two are equal. These two are equal. So he must be trying to ask the terminal voltage literally, maybe. Okay, that's the only possible way. Okay, that's the only possible way. So let me take this terminal voltage. Terminal voltage will be, this will be the other side. This will go to the other side. This go to the other side, plus IA, RA, some drop. Okay, so these two values, if they are same, this terminal voltage of a motor, this terminal voltage of a generator, this will be more, this will be more. So option 4 is right. Option 4 is right. 2 and 4 means C is right. Are we clear, guys? Are we clear? See, there is an ambiguity here, obviously, because armature voltage of a generator means, first I considered this one as induced EMF, but actually he's trying to say the terminal voltage, because induced EMFs of both the machines are exactly the same in case of a field test, because phi and N are exactly the same. There is no difference. Okay, not even a slight difference also. In case of a Hopkinson test also, they are almost same, not exactly the same. Hopkinson test, generator excitation is a little more compared to the motor excitation, but here they're exactly the same. So with that, we're doing little jugglery of mathematical jugglery here, taking this to the other side and all. So we got this to be more means this right answer. I hope it's clear. Next, sir, will you do the complete PS Bhimbra series of machines? Shashidhar 1, 2, 3. Yes, we're doing it. It's almost, we're at the 110th question or something. No, 120th question, I think. We have done 12 parts. We're at the 13th part. We are not just giving the answers. We are giving detailed explanation for each and everything. Yes, we'll get it. And we're going to give you a session also on our test series also. We're going to launch on this. Don't worry. Yeah, we'll be doing it. But you have to at least, you guys are not even liking this also. Forget about the share. You're not even interacting. You're not even liking. So, what's the point of doing all this? Our team needs some encouragement, right? So, anyways, I know you're not going to do it. Anyways, let's see this. Yeah, we'll see based on your response. And all, I'll try to continue. I'll decide whether to continue or not. All right. For now, just focus on this. Where the 13th part, we'll see further. Next, final question, I think. Final question of the day. Or we have one more question? Yeah, one more question is there after this. Wow, we already got the answer by Sumit. Sumit is rocking today. Other people are just waiting. Quickly, let's see. Very beautiful thing. Retardation test. There is something called retardation test. Retardation test is used for separation of stray losses, separation of iron losses and friction losses. Okay. Retardation test is for this. Okay. D is 2. So this is wrong. Okay. Either option A or C is right. So you don't have to check 3. A is mapped to 3 because they are same. A is mapped to 3. Yes. And you even know this. Voltage drop test. Of course, it is not so familiar to you in case of a DC machine. We will not do a voltage drop test. In case of a synchronous machine, though, we will do the voltage drop test. Have you heard of this voltage drop test in case of a synchronous machine? That's what during voltage regulation method, by using synchronous impedance method, you will draw open circuit curve, you will draw the short circuit curve, and draw the diagram and find the voltage drop. That's what the voltage drop test. Okay, because in case of a synchronous machine, IAZS is responsible for voltage drop, and you can find out RA by using VA method or maybe simple multimeter. You can find out the resistance of an armature, but synchronous impedance is hard to find, hence you are forced, you must go for this method or any other method to find out excess. Okay, but in case of a DC machine, there is no such inductance will cause a drop. Okay, though inductance is present, but inductance will not cause a drop on an average, because we're talking about average voltage. Okay, so that will not cause any drop. So you can find out a resistance by using VA method or your regular multimeter method. Okay, but if you had to go with the regular method, regular in actual process, voltage drop test can be found out by using open circuit and short circuit test, just the way you're doing for synchronous machines. Okay, so but anyways, you don't have to worry about it, even you don't know all of these shit, because it is same for all of these two options. Now you have to figure it out either option B, and you have to match either B or C. Swinburne test. Swinburne test is to find out efficiency. It's a no-load test. It is to find out the efficiency of a DC shunt motor. It's a straight away thing. Okay. Yeah, efficiency. Yes, it cannot find temperature rise. This cannot find temperature rise. This is, yes, efficiency. Hopkinson test, efficiency finding, and also temperature rise. So B, yes, efficiency, but temperature rise, this is the only option left. So B is option 4. So option C is right. Option C is right. Absolutely. Sumit. For Sumit, give it a thumbs up. Give it a thumbs up for Sumit, guys. Give it a thumbs up for Sumit. Let's go to the last question. Boom. I already gave a brief of these in our courses. Okay. Constant current source. If somebody asks, what is the current source example? You know, if it is a voltage source example, everybody will talk about a battery, the X, Y, Z, all those. There are a lot of examples to give a voltage source. But what is a current source example? Current source itself means constant current, by the way. Okay. Then people get stumbled. So just give me the examples of current source, what you know and what I said in the courses, because current source is not actually readily available. You have to build it. You have to make some circuitry to get the current source. Give me some popular circuitries. Yes, guys. What are the popular examples of current source? You know, you got stuck. This is one of the interview questions. Now, if you give the answer as metadine, wow, you will get a job, man, for sure. If you expect this, if you get a question like this, what is the example of current source? That's an opportunity for you to bag the job. How? You simply don't give the regular answers the way people, you know, some people may give. Yes, absolutely true. Solar cell is one of the examples of current source. That's true. And current mirrors, that's what the through electronic combination, through transistors and all, you can build the current source. That's what the current mirror, that's what one of the examples of current source. But if you're an electrical engineer, current mirror, current mirror. Okay. But as an electrical engineer, yes, you can give these two definitely, but metadine, if you give it, I think you will get good points in an interview. Okay, it's a rotating amplifier that can be used as a rotating amplifier. It can be used as constant current source or simply current source. If you talk about amplidine, if it is amplidine, it is actually power amplification purpose. Okay, you'll get to see all of those in the course. Regulax and rotorol, I don't know. I have not come across these two terms. If you have come across these two terms and if you know about these two, let me know. For now, question is option A. Okay, I mean answer is option A. Amplidine is not the answer, but these two are, I don't think they're relevant anymore to electrical engineering, but I don't know as far as my knowledge, but if you have some idea about it, you can share in the comment. That's it. That's end of this 13th part of PS Bhimbra. Okay, 13th part. Good understanding. Not just, if you directly watch these, question series without having the understanding of the course, it is of no use, believe me. It is of literally no use. Because you are going to brush or enhance the concepts what you learned here. Without knowing the basics, it's useless to watch these kind of MCQ series, any MCQ series for that matters. You build the knowledge, and nowadays building the knowledge is very cheap thanks to online courses. You go to any institute. If you want our institute, yes, you visit our institute, our website. We have beautifully animated courses. Individual courses are there for DC machines. Just focus. If you want to start machines, you must 100% ensure to have a confidence on DC machines first. Okay, you master these DC machines. It is very low price, believe me. Okay, very low price, believe me. And beautiful animation courses which you'll never get anywhere. That's what PiSquare style. What is PiSquare? PiSquare tag is we help in bridging the gap with multiplied effort. We are doing the multiplied effort for you guys. Are you ready to bag it? Capture it. If you're ready, see you on board. Happy learning. Enjoy the learning in PiSquare style. Have a good time. Bye-bye.